Hello everybody, I am Dr. Emre Süren. In this lecture today, we are going to use Cursor desktop agent to perform vulnerability research. In our previous lectures, we have been using Fire as a desktop agent. Now we will try another agent, which is Cursor. Cursor, we are quite familiar with Cursor because we are using in our daily life to develop code. But in our case, now we will use agentic features of Cursor platform. Let's remind our target. Our target runs on 150.1. This is the 5000 port number of the service. And this is the Kali machine. Kali and this web application doesn't run in the same machine. They are different devices. But this Kali instance has an access to this web application because Kali will perform actual actions against our target. So come back to our agent, which is Cursor. Let's see how Cursor connects to our Kali. What was our method? MCP, yes. And these are the settings regarding Cursor. And we are interested in tools and MCP. In our MCP service, you will see Kali MCP here, which provides different capabilities. And we have studied those before in our previous lectures, and it is enabled right now. Second, in our previous exercises, you know that we need to develop some prompts to guide our AI agent. Why? Without context, an AI model will try a lot of things. But trying something means also burning tokens, which translates to burning cache. That's why we want to tailor our desktop agent to focus on specific methods, which will allow us to cost less. So that's why I'm going to show you our rules, skills, and sub-agents. This is the terminology here. In Fire, we were using system prompts and user prompts, where we were providing our one-shot learning or methodology instructions. Here we are embedding this knowledge inside playbooks, actually rules. So this is one of my target here, JWT. JWT contains a vulnerability regarding JWT, and this rule file contains instructions regarding how a vulnerability researcher can find vulnerabilities. In JWT implementation here, AI vulnerability researcher, this is the personality which contains system instructions, and playbook JWT contains user instructions, specific instructions, and so on. Without further ado, let's get started. I'm going to maximize this part and we will provide our target information, right? Target is 192, 168, 150, and 1. We don't provide the port number because we want our agent to discover it by using our MCP tools and run playbook JWT. Okay. We don't need to write exact name. It is a model, AI model, which understands by name. So our desktop is running. Our MCP client, which is embedded to Cursor, is running, which connects to our MCP server, which is running, which connects to Kali terminal. They are running, and our target is running. So we are ready to run. For example, as you see, I wrote IP address manually, but in our previous exercises, we were using different agents. We were bringing IP address automatically because we had options, capabilities to embed user prompts. Here, Cursor, the logic is a bit of different. It's not designed just for being AI agent. It's a code development platform, but it provides significant capabilities, especially letting us access to latest models. But I am letting it to select the model itself because it is better in that point. So now we are ready to run. Now it is planning the action, probably reading the playbook. It created a file also to log actions. Querying the tools through MCP client and learns how these tools runs, actually how Nmap runs. This is the first execution. Nmap, it says command does not found. Let's go here. These are the commands that our client executed. Now it's going very fast. It discovered the login page. From here I understand, because it ran this Hydra command. It provided Mirai word list, but YFT as a password. It's using another list. This is the target. This is the form. This is the payload. Here, for example, in our instructions, we don't have -v, which translates to verbose outputs. So even if we embed the usage of tools in our MCP client, it does not follow always, because it also knows information about Hydra. It tunes the command. But now I guess it tuned in a bad way. That's why it is taking so long. As far as I remember, normally Hydra can break this username, password, credentials around 30 seconds. But let's try. This is our agent, it's still trying. Let's see the logs from our target. So as you see, we have post requests, Hydra password file. I'm not sure why it selected this YFT. Maybe, I'm not sure, maybe Kali MCP suggests running in that way. Hydra configuration in MCP client may contain default values. That's why our agent might rely on this. Other than that, I don't find any explanation for this. Meanwhile, we can also it contains almost 200,000 entries. In Mirai pass, there are 43 entries. Mirai user, 15 entries. It would be really reasonable to select Mirai user and Mirai pass. Unfortunately, it didn't select. Terminating the process. Allow MCP tool. Checking the help. Now I'm going to also check MCP tool. Okay, memory related issues, because it makes I/O, network communication, network socket operations. At least our Kali MCP server didn't hang. Sometimes, you know, MCP server freezes. Here we are not running this issue. Still we run. It created a Python file and trying to use. Unfortunately, Kali MCP tool started to produce errors. That's why it switched to develop its own scripts. It found credentials successfully. Now found a feature regarding file upload and trying to upload one test file. Trying to access the uploaded file. Trying to access the flag. I guess it discovered a link which gives an access to the flag, but it didn't work. Now it studies JWT content and identified two different variables like ISS and approve, which looks it is not approved. Now it is modifying it to make it approved, but it needs to sign because it edited the cookie. So that's why it is trying to find a way how it can validate on the server side. That's why I created a public and private key. As you remember, there was a file upload feature. That's why it's gonna upload the public key, because it will be used to verify the signature. Private key provides the signing operation. So it signed the cookie with the private key and uploaded the public key, but also changed the ISS value to the uploaded location, because JWT gets the location of the public key from the cookie. So it uses these keys, but which is also modifiable by the user. I was planning to show these rabbit holes in another lecture, but unfortunately we run into this issue in this lab. As you see, if you cannot guide your AI agent properly, it will burn tokens that you cannot imagine. I am 100% sure we are now running 10 times higher tokens, and every call increases our consumption also. I'm just trying to see what's gonna happen. That's why I'm accepting what it suggests. We also understand that I need to improve this Kali MCP Python implementation. It is super good at developing code and scripts. As you see, the tools provided by Kali didn't work. Now it develops its script. But how this can happen? Kali provides Nmap, Nikto, GoBuster. How this can happen? This is super important. You need to give flexibility to your AI agent when it requires fallbacks. For example, you can give terminal access. Here, I provide this capability. Directly accessing to terminal, plus running this MCP server on the Kali side in a writable directory so it can write files. If I have configured this AI agent to execute everything automatically, you would never see what is happening. You would see the final result. Now we see how many tries, how many scripts are generated on the fly. But we don't have enough time to explore the content of the script. Now we are just waiting for the results. As you see, payload now is true. It's gonna record everything it has done. Fantastic. Let's review the file generated. I'm going to the final line to see if it discovered the flag. Restore Kali MCP tool availability. Okay, it couldn't discover the flag because it is not able to sign it with its capabilities. In this target, we have a JWT signer run tool, which allows to edit the content of JWT cookie as well as sign it. Now what I'm gonna do, I will go here, settings, stop it, run it again. Here it's running, but still I'm going to close it, clear. Now you see the IP address of the Kali, and this is the IP address of the target. Now I'm going to stop it, run it again, and here we go. It discovered the open port 5000 TCP. Now it is using Mirai password in the second try. Probably it will find relatively faster. This is what we are expecting. It confirmed the username and password. As you see, now it took just a couple of minutes to complete with a different password. Just selecting a correct password list changed the way it ran dramatically. Just because Hydra was running so long, it broke MCP server. Now I'm keeping this information into my notes, so I will fix this MCP server in the upcoming days to make it more persistent regarding when we need to create several sockets. Now it is uploading the public key to the remote server. Once it doesn't print any messages, either it falls into error or there is no relevant information for us. That's why it is not bothering us. Now signing the created token. Yes, it got the flag. This is our flag. Once it completes, engagement log, say keep it all. These are the steps to perform the penetration testing. Reconnaissance, it used Nmap commands. Web application analysis, it mainly used curl as well as Hydra. File upload, mainly used by curl to discover vulnerability in file upload feature. Then it found a vulnerability in the JWT token. Especially this JWT token manipulation is contained in our JWT playbook execution. You know the content of this file in our previous courses. And this is how it accesses. First creates a public private key, uploads it to the server, then edits the JWT token, then signs the JWT token with the private key, then sends a request to this endpoint and gets the secret flag. Heja Sverige. I am Dr. Emre Süren.